Hi, Assalamualaikum students. This is the very first tutorial video, tutorial 01. So in this video, we are going to cover tutorial for chapter 1.2, and we are going to cover from question number 3. And I know question number 1 and also number 2 we have covered in the class. So we are going to continue question number 3 for tutorial chapter 1.2. Question number 3. Water in a piston cylinder device is heated at constant pressure through the following processes. Process number 1. Water is heated from 20 degrees C and 20 kilopascal to saturated liquid state. Process 2 to 3. The heating process is continued until all liquid vaporized. Process 3 to 4. The system is further heated until the temperature reached 80 degrees C. So question A, identify the phases of water at state 1, state 3 and also state 4. B, determine the temperature at state 2. C, sketch the processes on a TV diagram. So we are given 3 processes from state 1 to state 2, process number 1, state 2 to state 3, process number 2, and state 3 to state 4, process number 3. So question A, we need to identify the phase of water at state 1, state 3 and also state 4. Right, so according to the question, state number 1, water is heated from 20 degrees C and 20 kilopascal. Means that at state 1, the temperature is 20 degrees C and the pressure is 20 kilopascal. So in order to find the phase of this state, we need to consider on T and also P. We open table A4, we look at 20 degrees C, so we have to identify whether the pressure is over the P saturated or lower than the P saturated. So the P saturated at T 20 degrees C is 2.3392 kilopascal. So it means that this P is higher than this P saturated. So P is higher than P saturated. So because of P is higher than P saturated, according to the phase condition, it can be categorized as compressed liquid. Okay, so state number 1, the phase is compressed liquid. So state number 3, we read process 2 to 3, the heating process is continued until all liquid vaporized. Okay, the keyword there is all liquid vaporized. When we see that, we already know it is saturated vapor. Okay, state number 4, the system is further heated until the temperature reach 80 degrees C. It is stated that the pressure is constant. The temperature is 80 degrees C, so the pressure is remain 20 kilopascal. Right, so we do the same as state 1. So we find from table A4 as well. So for table A4, we check at 80 degrees C. Table A4, we check at 80 degrees C. So the P saturated is 47.416 kilopascal. So when we compare P saturated and the P given here, the P given here is lower than the P saturated. So according to the phase condition in your lecture notes, when P is lower than P saturated, we can categorize as superheated vapor. Question B, determine the temperature at state 2 according to the question. So we read process 1 to 2, water is heated from 20 degrees C and 20 kilopascal to saturated liquid vapor. So when it is mentioned it is saturated liquid, so means that we just to refer to table, saturated table, which is table A5. We refer at table A5. P is 20 kilopascal, and we just look at the temperature here is temperature saturated, which is 60.06 degrees C. Why we choose P 20 kilopascal? Because of it is already mentioned that through all this process the pressure is constant, so that's why we use a P 20 kilopascal. And because of we are going to refer to the saturated table and we have pressure, so we refer at table A5 because table A5 is pressure base. So from P20 kilopascal, we know it is already saturated, so we just take the T saturated as temperature at state 2, which is 60.06 degrees C. Okay, now question C. Sketch the processes on a TV diagram. Okay, so TV diagram is basically we should sketch with respect to the saturation line. So this is the saturation line, state 1 to state 2. So state 1, it is compressed liquid. Okay, it is compressed liquid. Compressed liquid is in this region. Okay, left hand side of the saturation line. This is saturation line. Okay, it is somewhere here, which is 20 degrees C. Okay, next state 2, all the water is in saturated liquid state. So the saturated liquid is on the line. So saturated liquid is left hand side here, and the saturated vapor is right hand side here. So it is saturated liquid, right? So this is 1, this is 2, so it is 60.06 degrees C. Okay, state 3, the phase is saturated vapor. It should be here. This is 4. Okay, 4. Then state 4, here we already identify the phase for state 4. It is superheated, but the temperature is 80 degrees C, so it is somewhere here. Here. Oh, sorry, this is 3. This is 4. So this is how you draw the TV diagram. Next, question number 4. A rigid tank with a volume of 2.5 meter cube contains 15 kg of saturated liquid vapor mixture of water at 75 degrees C. Now the water is slowly heated. Determine the temperature at which the liquid in the tank is completely vaporized. First, we draw. It is a rigid tank. So in this rigid tank, it says it contains a saturated liquid vapor mixture. Okay, in which some portion is liquid, some portion is vapor, and the temperature is 75 degrees C. The water is slowly heated. It is heated. Okay, it is heated so that the liquid in the tank is completely vaporized. Okay, just like in question number 2, when it is completely vaporized means that all of the water in here it become saturated vapor. We need to find the temperature at state 2. This is state 1 and this is state 2. Okay, for state 1 we have temperature 75 degrees C, and for state 2 we don't have any info, so we look the other info that been given. Other than temperature, you are given with the volume is 2.5 meter cube, and also the mass is 15 kg. Okay, so from here we can find the specific volume, V over M, 2.5 meter cube over 15 kilogram. So it will become 0.1667 meter cube per kg. So we have to remember this is saturated mixture. The phase is saturated mixture. We need to remember the device used in this question is rigid tank. And one thing that you have to know in rigid tank, the volume will not change. Whatever it is, the volume will not changing. So it means that for state 1 and state 2, both V is equal. V1 is equal to V2, and this V2 is equal to V1. Okay, so rigid tank, no change in volume. Okay, so in order to find T at state 2, we need to have at least two info. First info is saturated vapor, and the second info is V2. Right, so we know already V1 we have calculated before, which is 0.1667, and it is equal to V2. So it means that V2 is equal to V1 is equal to 0.1667 meter cube per kg, and the phase here is saturated vapor. Because of it is saturated, we can just find any info or any data from the saturated table. It is either table A4 or table A5. Because we want to find the temperature, it is better for us to use table A4, because of table A4 is the temperature base. From table A4, one of the info that we can get is volume. We have already volume here, which is 0.1667. Because of it is saturated table, so we can find the T from the T saturated. So T here is equal to T saturated. This is T at state 2, okay? T at state 2, we just find the T saturated. V is equal to 0.1667, and we find where is the location of 0.1667 in table A4. It is located at temperature 187 degrees C. So that is how we find the temperature. Next, question 5. A rigid vessel contains 2 kg of refrigerant 134A at 800 kilopascal and 120 degrees C. Determine the volume of the vessel and the total energy of the vessel. Okay, so we have a vessel. This is actually rigid tank. I call it as vessel. It is rigid tank. In that vessel, we have the refrigerant. Okay, the refrigerant 134A, and it contains the mass is 2 kg. The pressure is 800 kilopascal, and the temperature is 120 degrees C. In order to find the V and also U, okay, V is volume, U is internal energy. So we need to identify first what is the phase of this refrigerant inside this vessel. Okay, so we have temperature is 120 degrees C and pressure is 800 kilopascal. So we are going to find what is the phase of refrigerant in this vessel. So we open table A12. From table A12, we find what is the T saturated at P 800 kilopascal. So at 800 kilopascal in table A12, the T saturated is 31.31 degrees C. So when we look at here, T here is higher than the T saturated. So according to the phase condition, when T is higher than T saturated, it is superheated. So we refer at table A13. So in table A13, we can directly get what is V and also what is U. But in table A13, we can get the specific V and also the specific U, the specific volume and also the specific internal energy. So from table A13, specific volume is 0.037625 meter cube per kg. For specific internal energy, it is 327.87 kilojoule per kg. In order to find the volume and also the total energy, we need to multiply with the mass. Okay. It's supposed to be U in the capital letter. So U in the capital letter is total internal energy. U in the small letter is specific internal energy. G multiply with what we get from table A13. So we will get 0.0753. For U, let's go to M, U. Is equal to 655.7 kilojoule. So that's how we find the volume and also the total internal energy. Next, question 6. A 0.5 meter cube vessel contains 10 kg of refrigerant 134A at negative 20 degrees C. Determine A, the pressure, B, the total internal energy, C, the volume occupied by the liquid phase. We have a vessel, and in that vessel we have refrigerant 134A, 10 kg, negative 20 degrees C, and 0.5 meter cube. A, we need to find the pressure. So from this vessel, we have the info of T is equal to negative 20 degrees C. And by using this info, it is not enough for us to use the property table. So we need another info. So we need to find at least two info in order to get P. Okay, here we have the volume and also the mass. So we can find the V. So V is equal to 0.5 meter cube over 10 kg. So this V is actually the specific volume. Okay, so from this info we can get the specific volume, which is 0.05 meter cube per kg. Okay, so now we have two info already, T and also V. So because of we have two info, now we can use the table. So first we need to identify what is the phase for this refrigerant. Okay, I always remind you, whatever it is, find first the phase. Okay, so now we have T negative 20 and V is 0.05. First we start with saturated table. So we look at table A11. At T is equal to negative 20 C, so we check whether this V is between VF and VG or not. So after we have checked, V is between VF and also VG. This value is between VF and also VG at T is equal to negative 20. So when it is between, according to the phase condition, it is saturated mixture. When we confirm it is saturated mixture, so we just find any data from the saturated table. So it includes pressure. So pressure here is equal to P saturated. Because of what? It is saturated mixture. Yes, indeed, we need to find any info from the saturated table, which is table A11. So at T is equal to negative 20 degrees C, we just find the P saturated. Because of what? The P saturated is actually our P. So the P saturated here is 132.82 kilopascal. So that's how we find the pressure. Next, B, we need to find the total internal energy. Okay, we know already the phase is saturated mixture. When it is saturated mixture, we have to know that we will use this equation. V is equal to Vf plus X Vfg. Okay, so in order to find internal energy, we need also to use this equation, which is U is equal to Uf plus X Ufg. So just that, we need to find the X. How to find the X? By using this equation. So we already know the V is here 0.05. So how to find X? We just rearrange the equation until we get this, V minus Vf over Vfg. So X is equal to V 0.05 minus Vf 0.0007362 over Vfg is Vg minus Vf 0.1214729 minus 0.0007362. So we will get the X is 0.3361. So by using this X, we can substitute in here. So from table A11 at T negative 20 degrees C, so we can get all the info for Uf, also Ufg. Okay, Vf, Vfg also we can get from table A11 at T is equal to negative 20 degrees C. Okay, so from here the U, what we get from the table A11 at T negative 20 degrees C, we will get a Uf 25.39 plus X is 0.3361 and the Ufg is 193.45. So U we will get 90.42 kilojoule per kg. So how to get U? Internal energy, U is equal to mu. This is capital letter of U, okay? It's equal to M, already have here, 10 kg multiplied with 90.42. So we will get 904.2 kilojoule. Okay, now we have to do question number C. So in question number C, we need to find what is the volume occupied by the liquid phase. So we already know that the phase for refrigerant in this vessel is saturated mixture. So just now we already calculate the quality. Because of what? Saturated mixture, of course we are going to have quality, which is 0.3361. Now we need to find the V for liquid. V for liquid. How to find the V for liquid? We need to find the M liquid multiplied with Vf. The Vf is actually V for saturated liquid. Alright, so at T is equal to negative 20 degrees C. Okay, we're going to use Vf at T is equal to negative 20 degrees C from table A11. So before we calculate it, we still don't know what is the mass for liquid. We cannot use this because of this is the mass for mixture. So we need to find the mass for liquid. So we have this quality equation, which is X is equal to M vapor over M total, or 1 minus X is equal to M liquid over M total. So we can use this equation. So now in order to find the M liquid, we just rearrange the equation like this. So X we already get 0.03361. So the M total is 10 kg. So the M liquid we get is 6.639 kg. Now we want to find the V liquid. So we can use this M liquid, and VF here we can find from table A11 at T is equal to -20. So VF here is 0.0007362. So from this value we can get the V liquid is equal to M liquid is 6.639 multiplied with 0.0007362. So we will get 0.00489 to cube. So that is how we solve question number 6. Now question number 7. 100 grams of R134A initially fill a weighted piston cylinder device at 60 kilopascal and -20 degrees C. The device is then heated isobarically until the temperature is 100 degrees C. Determine the change in the device volume as a result of the heating. We have a piston cylinder. So first, it is contained by R134A, 60 kilopascal, -20 degrees C, and it is 100 gram. So then the piston is heated. So when it is heated, the volume is changing, and the temperature now is 100 degrees C. So the volume here is volume 1, and the volume here is volume number 2. This is state 1 and this is state 2. So now we need to find the change in the device volume. Means that we need to find the delta V, which is V2 minus V1. Okay, so we need to find the volume at state 1 and also the volume at state 2. And because of it is the process happened isobarically, so the pressure here is 60 kilopascal for A. So we need to find the V1 and also the V2. Whatever it is, we need to find the phase of each state. State 1 and also state 2. Using pressure and also temperature, we can find what is the phase for this state. And from the table A11 at T -20 degrees C, we have found that the P here is lower than the P saturated. So according to the phase condition, when P is lower than P saturated, it is superheated. When it is superheated, we just go to table A13. From table A13, we check at temperature -20 degrees C and the pressure is 60 kilopascal. So we will get the specific volume is 0.33608 meter cube per kg. So this is a specific volume, so we need to find the volume. Okay, so in order to find the volume, so we need to multiply with the mass. So the mass here is 100 gram or 0.1 kg. 0.8. So the volume is 0.033608 meter cube. Okay, So settle V1, and now we need to find the V2. So V2 same as state 1, so we need to identify first what is the phase. So how? Similar to state 1, we check at table A11. So we check at 100 degrees C. So we check whether the P is higher or lower than P saturated. So after we have checked from table A11, so the P here is lower than the P saturated. So according to the phase condition, same as state 1, it is superheated. Okay. So when it is superheated, we just go to the table A13 and we can find the V. So the V is 0.5041 meter cube per kg. So in order to find V2, we should multiply with the mass, and mass is not changing, okay? Is equal to 0.0504. So after we get the V2 and also the V1, we substitute in here, so we will get the change of V. So the change of V is equal to 0.0168 the cube. So next, question number 8. Determine the mass in kg of 0.1 meter cube of refrigerant 134A at 0.4 megapascal and 100 degrees C. So here we need to find the mass. So mass we can find through volume over specific volume. So from the question, it is given to you that the volume is equal to 0.1 meter cube. P is 0.4 megapascal and T is 100 degrees C. In order to find specific volume, we can use P and also T. Okay, so this is refrigerant. We can refer to table A11. We check at temperature 100 degrees C and we look whether P is higher or lower than the P saturated. So after we have checked, so the P here is lower than P saturated. So according to the phase condition, when P is lower than P saturated, it is superheated. Once we know what is the phase for this refrigerant, so we just go to table A13 by using this P and also T. At table A13 we can get V. So V is 0.073274 meter cube per kg. So now we can calculate the mass. Mass is equal to 0.1 meter cube over 0.073274. So it is equal to 1.3647 kg. So that's how we solve question number 8. Alright, next, the last question. Determine the specific volume of steam with molecular weight of 18 kg per kilomole at 600 degrees C and 1 megapascal using A. Steam table, B. Ideal gas law. Okay, first we look at the steam table. So you are given with info of temperature 600 degrees C and also the pressure is equal to 1 megapascal. Because you are given with both temperature and pressure, so you can choose which one to use. For me, I will choose pressure. So I will look at table A5. So I look at 1 megapascal and I check whether this temperature is higher or lower than T saturated. So after I have checked, the T is higher than the T saturated. According to the phase condition, when T is higher than T saturated, the phase is superheated. So once we know the phase is superheated, we go straight to table A6. So at T 600 degrees C and pressure 1 megapascal, so we can find the specific volume is 0.4011 meter cube per kg. Next we go to ideal gas law, and of course we need to use the equation PV is equal to RT. So we rearrange V is equal to RT over P. So where can we get the R? We can get the R for water, okay, from table A1. So R for water is 0.46 Pascal meter cube per gram Kelvin. So R we already got, so we can substitute into here. So it will become V is equal to 0.46. T is in Kelvin, 600 plus 273.15 over P is 1 megapascal or 1000 kilopascal. So we will get the answer 0.40158 cube per kg. So when we compare for both, it is quite similar. So that is how we solve question number 9. So I think that's all that we can cover in this tutorial session. So I hope you can understand and meet me again in the other video. Thank you and Assalamualaikum.